Hello, welcome back to Mr. Channel. Thank you for click this link. So today we are going to discuss about the summary for lesson week 3 and week 4. So first we are going to roughly go through what should we focus when we answer the question about concentration measurements. Next, we will go through the balancing redox equation, and the last is the determine limiting reactant. Let's start with concentration measurements. To answer this question, it is good that if you can differentiate solute, solvent, and solution. Next, we have to know the 5 formula of the concentration measurements. As there is 1 cup of coffee, basically actually we can measure their molarity, mole fractions, percentage by mass, and even percentage by volume. So the list here it shows the formula of these 5 concentration measurements. Now let's proceed to the exercise 5 in the notes. Calculate the molar concentration of a solution by preparing dissolving 0.3 mole of copper 2 chloride in 40 mole of water. So from here we have the idea that copper 2 chloride is the solute while water is the solvent. So first we have to list down the formula for the molarity. So the formula for molarity is mole solute, which is copper 2 chloride, over the mass solvent, which is the water, in kilogram. So based on the information given, we have the mole solute, which is 0.3 mole. And next, from the mole of the water, we're able to determine mass of water. So mass of water is equal to 18 gram per mole multiplied with the 40 mole. So per mole and mole cancel out. So we were able to get the mass. And then don't forget the mass is in the unit of gram. So we have to convert to kilogram. Then we can substitute the value into this formula and we're able to get the answer. For exercise 5, we no need to do the assumption. So now let's proceed to question exercise 6. Check out whether we need to do assumption or no. Okay, first the question asks us to determine the mole fraction. So what is the formula for mole fraction of NaOH? Mole fraction NaOH equal to mole of NaOH over total number of mole. So when we read this question, we can see that NaOH solution, sodium hydroxide solution. So there is no significant solvent is mentioned, so we will treat that is the mole of the solvent is water. So means that the total number of mole is mole of NaOH plus mole of H2O. So look at the information given. The question let us know 10.5 molar, which is mole NaOH over with mass H2O in kilogram, and also density is the density of solution 1.33 gram per ml, so it's equal to mass solution NaOH solution over volume NaOH solution in the unit of gram and per ml. So based on the questions, we have no idea what is the number of mole of NaOH, mass of water, mass NaOH solution, and volume of NaOH solution. Therefore, for this question, we need to do assumption. Next, we look at the last question, which is the exercise 7. 40% by mass of hydrochloric acid, and then density of solution is given. So again, we want to determine the mole fraction of HCl. So formula for mole fraction of HCl, mole HCl over mole HCl plus mole H2O. Again, based on the formula given, percentage by mass, which is the 40% means equal to mass solute over mass solution multiply with 100%. So from the question, we didn't have mass solute. We also have no mass solution. It means that we are not able to determine number of mole of the HCl. So if we look at the density of the solution, similar case happened. We didn't have the mass of the HCl solution or hydrochloric acid, and also the volume of the HCl solution. So that's why for this question 7, we also need to do assumption. So I hope with these 3 examples, you will have the idea how to know whether the question need you to do assumption or no. Okay, now let's continue to the second part, which is the balancing redox equation. If we are balancing in acid condition, basically these are the steps. So from my observation, majority of the students have no problem in separate to 2 half equation, balance other elements except hydrogen and oxygen atom. And then you all also know balance oxygen using H2O and balance hydrogen using H+. So before we proceed to next, balance is in bahasa means seimbang. So we have to make sure number of hydrogen at the left hand side and right hand side are similar. So what I notice is student normally maybe will be a bit confusing for step number 5. Balance the charge by using electron, and the electron always either at more positive side or less negative. Choose either one to remember and practice when you are answering the questions. So now let's look at one example here. For example, if we have Fe2 plus to Fe3 plus, so the charge for Fe2 plus is positive 2 and the charge for Fe3 plus is positive 3. So in between these two, now we want to balance them. So we make a symbol equal in between them. So positive 2 and positive 3. Positive 3 is more positive. So I will add plus x here. So this x is represent number of electrons that you going to add. And then if the x is at the right hand side, means that you have to add the electron at the right hand side. So just like doing mathematics, pass 2, positive 3 move to another side will become negative 3. So end up the x value is equal to negative 1. So this negative 1 means that you have to add 1 electron at the right hand side, as the x is at the right hand side. So plus electron. So how about we go for another example? This is the second example and also the last example that I will show in this video. So the charge for Cr2O72 minus is negative 2 plus 14 H plus, and each H plus the charge is positive 1. So when we see this error, we can use equal to 2 times positive 3 plus 7 times 0. So negative 2 plus 14 equal to 6 plus 0. So positive 12, and this is 6. Basically is positive 6. So in between positive 12 and positive 6, positive 12 is more positive. So I will add plus x over here. So what will be the value of the x? So x equal to positive 6, positive 12 move to here. So will become negative 12. Then end up the answer is negative 6. What does this mean? this -6 is represent 6 electron. So where you will put the 6 electron at more positive side, which is +12. Follow the X sign. So here you will put 6 electron. I hope it is clear for this step. After adding the electron at the correct side, so we will proceed to step number 6. We will balance the electron for both equation. Then we sum up the two half equation. So let's say if the question asks for basic medium, we will continue with state 8, 9, and also 10. So based on the 8, add OH minus to both sides of the equation to eliminate H plus. So we look at here, if there is 14 H plus, means that I am going to add 14 OH minus at both sides. So not just the left hand side, but and also the right hand side. Okay, this is to ensure that all the elements at the left hand side and right hand side are balanced, including the charge. Okay, next we are going to combine the H plus and OH minus to become H2O. So that's why we will have 6Fe2 plus and one more dichromate ion and also 14 H2O and produce 6 more of Fe3 plus, 2 more chromium 3 plus, 7 H2O and also 14 OH minus. Now we go to last step, which is simplify. So simplify here can be total up if the H2O at the same side, or you cancel out if the H2O at the opposite side. So in this case, H2O are at the different side. So after we cancel out, at the left hand side here only left 7 H2O. So this is the final answer for the equation. Now look at another example. Here we have 2H plus. So in other words to say, we will add 2 OH minus at the left hand side and also the right hand side. Next, we are combining the 2H plus with the 2 OH minus to form 2H2O. So means that 2MnO4 minus plus 2H2O plus 3 more of NO2 minus ion and then produce 2 more MnO2, 1 more H2O, 3 more nitrate ion and 2 more of OH minus. So again, this time we also notice that the H2O is at different side. So we can simplify by cancel out. So here no more H2O and at the left hand side here only left 1 H2O. So I hope using these two examples you are clear that we always have to add the OH minus at both sides so that it will be balanced. And also combine H plus with OH minus to form H2O. And last but not least, so you will be simplify either total out or cancel out the H2O, depends on where the H2O located. Okay, let's continue with the last part of this video, which related with determining the limiting reactant. Basically, there are 3 steps. By looking at this question, exercise 3 in your notes. So here, you are given a chemical equation and then you are given 2 value of mass. So basically, the mass given in the questions is referring to number of mole of provided. So this question is asking us to determine limiting reactant. Check at here, step number 1, we have to determine number of mole for both reactants. And again, you have to keep in mind that they are referred to the number of mole of provided. So mole of vanadium 5 oxide equal to the mass 1540 over the molar mass, which will equal to 8.4708 mole, while the mole for the calcium will equal to 1960 divided with the molar mass of calcium 40.1, which is equal to 48.8778 mole. Okay, we have done for step number 1. So next we will go to step number 2, at where we have to compare both reactants, and there is one value that you need to calculate, and the value that you calculate is considered more of needed. So let's continue from chemical equation. 1 mole vanadium 5 oxide react with 5 mole calcium. While here we have 8.4708 mole of vanadium oxide. So when we press the calculator, we will need 42.3540 mole calcium. So this is like just now we mentioned, this is what we need. Okay, now we will proceed to step 3. We have to compare mole provided with needed. So this needed is referred to calcium, means that we will get the mole of calcium to do the comparison. Mole provided for calcium compare with mole needed for calcium. We need 42.3540 mole, while for the provider is 48.8778 mole. Means what provided is more than calcium, more than needed. So next we will going to ask, is that enough? So the answer is yes. In this case, the calcium is the excess reactant, while automatically the vanadium 5 oxide will be the limiting reactant. So these are the 3 steps that we use to determine the limiting reactant. After identify the limiting reactant, basically we can determine the theoretical yield. What is the meaning of yield? Another term for yield is product. So how much of the product will be produced is very depending on the limiting reactant. As once the limiting reactant is completely used up, no more product will be formed. So that's why we have to always compare limiting reactant with the product. So according to the questions, 1 mole of vanadium 5 oxide, as the vanadium 5 oxide is the limiting reactant, will produce 2 more vanadium. Next, we will use the mole provided in the question for the vanadium 5 oxide, which is 8.4708 mole, and hence it will produce 16.9416 mole of vanadium. So since this question is not mentioned whether it's supposedly in the number of mole or mass, so you can keep the answer in terms of number of mole. But if we roughly look at the next question, they ask us to calculate the percentage yield, and then the mass of the vanadium is given. So here basically I will directly to calculate what is the mass of vanadium produced. Once we have the number of mole, we can just multiply with the molar mass of vanadium, which will be equal to 862.32744 gram. Okay, so means that we can keep the unit for the theoretical yield in number of mole or either in mass. gram. Okay, next we will calculate the percentage yield if 803 grams of vanadium are obtained. So the formula for the percentage yield is actual yield divided by the theoretical yield. So from this here, we know that we already have, we are asked to calculate the percentage yield. The theoretical yield is calculated in question B1, which is 862.32744 gram, while the actual yield is given in the question, which is 803. So if we substitute the value here and we press the calculator in this formula, basically the answer will be equal to 93.12%. So do keep in mind that normally what you calculated will be the theoretical yield. Okay, what you calculated will be the theoretical yield, and actual yield is the one given in the question. Okay, beside from determining the amount of product formed by comparing with the limiting reactant, we also can determine how much of the excess reactant left over after we determine the limiting reactants. So basically, we can refer back in the step determining limiting reactant. So as we understand, more of the calcium left over, as calcium is the excess reactant, so is equal to more provided of calcium, which we calculated in step 1, is equal to 48.8778 mole, and then we minus with the more calcium needed, which we get the value in step 2 in the determining of limiting reactant, which is equal to 42.3540 mole. So the excess one, we do the calculation. The excess number of mole of calcium left over is 6.5238 mole. So what is the mass of the calcium left over? Very simple. We just multiply it with the molar mass, which is 40.1 gram per mole. Mole and per mole cancel out. Press the calculator, you will get the mass of the calcium. So we are at the end of this video. So again, this video is the summary for the content that you learned in week 3 and week 4. So if this video is helpful, please like, share with your friends, and also comment in below. Thank you for watching this. See you again.